Hey seniors! Today we're going to be talking more about data representations and reminding ourselves how to write equations from words. So let's go ahead and jump right in. This week especially, I'm really focusing on telling you all exactly what to write in these videos, so you only need to write down what I underline on the videos or what I tell you explicitly to write down. On your notes page, go ahead and write down our title for today, which is Data Representations and Writing Equations. Remember, every adult in this room knows what your notes should look like, so make sure that they look top high school ready. Okay, so just a reminder, when writing equations from words, look to identify the constant versus the coefficient. And just a reminder what a constant is a number that stands by itself. Let's just say our example 30. 30 is a number that stands completely alone, versus a coefficient is the number that precedes a variable. So if I had 30x, 30 would be my coefficient. Now, when I'm writing equations from words, I need to identify my constant versus coefficient. And your constant is a value that happens only once. You're likely to hear a constant referred to in a word problem as like a fixed rate or a one-time fee or something that only happens once. Whereas your coefficient is your value that happens over and over again and will be followed by a variable. So make sure you have constant and coefficient, which I underlined, in your notes page. Let's move on. Okay guys, let's try an example here, writing an equation and then filling in a table. Let's go ahead and read the first one. Haley wants to learn to windsurf. She can get instruction on windsurfing for $10. The cost of renting a sailboard is $5 per hour. Write a table that describes the scenario. Use at least 4 values. The first thing I need to do here is write an equation. So what I need to figure out is based on my two numbers that they gave me, $10 and $5 per hour, I need to figure out which is going to be my constant and which is going to be my coefficient. Remember, when I write equations from words, I want to use the form, our slope-intercept form, which is y equals mx plus b. Now, let's try to figure out which one of these will be our constant. What I want to figure out is which one is just a one-time thing. Well, if I go back to my problem, it says she can get instruction on windsurfing for $10. That $10 is going to be a one-time fee. She absolutely has to pay at least $10. So 10 is going to end up being my constant. The cost of renting a sailboard is $5 per hour. Since I don't know how many hours she's going to actually rent a sailboard for, that means that she's paying $5 over and over and over again for each hour that she rents. So that's going to end up being my slope or my coefficient. So my equation comes out to be y equals 5x plus 10, where y represents my total cost, and x represents the hours rented for her sailboard. Now, what I want to do with this information is go ahead and plug it into my table. So I have x on one side and y on the other side. And remember, x represents hours rented. Now, we recall from last week, whenever I have a blank table, I need to fill it in with values, and I always start small. So I'll have 0, 1, 2, 3. Now, in order to figure out what my y values are, I just need to plug my x values into my equation. So let's go ahead and do that. Okay, so my first value I'm going to plug in is going to be 0. So if my equation is y equals 5x plus 10, I'm just going to take 0, I'm going to plug it in for x. So I have y equals 5 times 0 plus 10. Now, 5 times 0 is going to leave me with 0, and then 0 plus 10, so y equals 10. Now, what that means in terms of real life is that if Haley does not rent a sailboard, for any hours, and all she does is get instruction on windsurfing, all she has to pay is the $10. Let's go ahead and figure out how much she'll spend if she rents a sailboard for 1 hour. Okay, so again, if I want to figure out how much she spends for 1 hour, I just plug in 1 into my equation. So my equation is y equals 5x plus 10. I just plug in 1 for x. So I have y equals 5 times 1 plus 10. And that's going to come out to y equals 15. 5 times 1 is 5, and then 5 plus 10 will leave me with 15. Now, hopefully you guys are starting to see a pattern here that this is increasing by 5 for every hour. So I can go ahead and fill in the rest of this table. If I were to plug in 2 and 3, if she rented a sailboard for 2 hours, it would come out to $20. Likewise, if she rented it for 3 hours, 5 times 3 is 15, plus 10 is 25, she would spend $25. Let's go ahead and move on to graphing our equation. Okay guys, one last thing we're going to do here is go ahead and talk about which answer choice accurately describes this relationship. I want to make sure that we understand relationships. The way we can figure out this problem about Lucy's weight loss is simply to find the equation of this line. Now I can already go ahead and see that 20 is going to be my starting point because that's where my line crosses the y-intercept. My next step is to figure out what the slope is. So I'm going to put a point where y is 20. My next clear point doesn't come until x is 5. What I need to do is figure out my rise and my run. So I see that I'm going to decrease by 20, and then, which is the same as rise, and I'm going to run 5. Negative 20 divided by 5 is going to leave me with negative 4. So I have a slope here of negative 4x plus 20. Now let's look at my answer choices. A, Lucy lost 5 pounds for 4 weeks. That can't be true because our slope here is 4, and our graph shows 5 weeks. Lucy lost 4 pounds for 5 weeks. That answer choice is correct because I have a slope here of negative 4, and it says that she lost 4 pounds for 5 weeks, which also is shown on our graph. So that's going to be our correct answer. All right, guys, that's going to be it for me today. Let's go ahead and practice.